Good morning. Welcome to AP Computer Science A. Today we are going to be covering sections 3.5, short circuit evaluation, and 3.6, De Morgan's law. And both of them are pretty simple. If you notice on your notes, you should have your notes ready with you. 3.5, that's 3.4. They are so short, those two lessons, that if you flip through too fast or scroll through too fast, you will skip them. 3.5, short circuit evaluation. One page, do a quick summary. 3.6, De Morgan's law. Do a quick summary. And they both are pretty logical. Now you should also have your repo ready to go. Make sure that you type in your name. Then don't forget to submit in order to be able to get full points for this. Now, if we go back to what we've been talking about, let's do short circuit evaluation first. Whenever we have if statements and we have the AND operator, so if we have if true and true, then we are going to print a statement. We just say system.out.println. This statement prints. This prints. This line prints. If we run it, it prints. That means that this statement is going to go through. That is the AND operator that we cover. In order for this statement to print, what do we need to have? Those two items must be true, correct? If by any chance this is false, then it won't go through. That means that this gets evaluated to false. True and false gives you false, so therefore it's not going to happen. It's not going to print. This statement is not going to be executed at all. It skips it. Therefore, when we are dealing with an AND, in order for this to be executed, we know that both of them must be true. And Java knows that as well. So therefore, if this statement is false, Java says, well, if that's false, why am I going to waste my time and think about this statement here? So therefore, if that's false, this statement doesn't even get executed. As soon as it says false and, then automatically this gets skipped. So it's just a simple way that let's say your dad, you want to go to a big party, you want to go to a big rave party this weekend on a Saturday night, and your dad tells you, you can go only if you take out the trash and you also clean your room. So it's 8 p.m., you're ready to go out, then your dad comes out, and there need to be two things: take out the trash and clean your room. He goes out and he looks and the trash is there. He's not going to waste his time to check to see if you clean your room, because there were two conditions. You failed the first one, you're not going out today. Same thing. So Java knows that that's false. It's not going to waste the time to be able to decide whether that's true or false, because whenever you have an AND statement, they both need to be true. So in order for you to go out, you need to do two things: take out the trash and clean your room. If your dad checks and the trash has not been picked up, has not been taken out, he's not going to bother, well, he should not bother looking at your room, because it doesn't matter whether you clean your room or not. You didn't do two things, and that was a condition for you to go out. That's basically what happens. And let's go and actually look at some code. So let's go and import. Let's go through the same process that we've done before. Let's go and import your scanner class, java.ut. So we can get some input from the user scanner. So we are importing our scanner class And the reason that we have to do this is because there's no file called scanner, so the class is not in here. It's not within the same location. And now let's go and declare and initialize our variable, scanner, scan. That is now our object called scan. And we are going to call up constructor. Scanner is the name of the class. And we have to get input from the user, so therefore we do system.in. That's going to allow us to get input from the user. Now, if you want to get input from a file, then this part will change. But that's not going to, we're not going to cover that in this class. And now let's go and say system.out.println. Enter your name. Not your name, your grade. Your grade. Same as before. Same code. So we can, and that way we can use it for the next lesson, which is 3.6. Let's go and declare and initialize a variable. So int grade equals scan is the name of the object. Next, int is the name of the method that we are using to get an integer. Therefore, if your grade, let's calculate to see if it's a B. If your grade is greater or equal to 80%, and your grade is less than or equal to 89, or let's say, no, 90, so let's just say less than 90. It's the same thing as less than or equal to 89, correct? So you have to be very careful with your and. Do I need an equal sign here, or do I not? You do not. If you decide to do less than or equal to 89, then you do end up, at that point, we're assuming that it's a integer. Now, if it is a double, then you do want to be able to get this statement instead. So it all depends. There's so many variables that you want to be able to consider, correct? So therefore, let's go and say, just in case we change to a double, let's go and keep this instead. Let's go and run it. Then your grade is 85. Well, let's go and type in your grade is a B. You have a B. Let's go and run it. Enter your grade 85. Whenever it's 85, Java will go through. Is the grade, which is 85, greater or equal to 80? Yes. And so because that's true, then it has to evaluate this one as well, because they both have to be true in order for it to be, this statement to be executed. Is the grade less than 90? Yes. So therefore, this statement on line 26 gets executed. Let's go and go through and run it again. Enter your grade 70. Now, because this is false, this never gets executed. Java doesn't even take a look at this. The same way that your DAO is not going to check your room. If you do not take out the trash, you are not going out to the party, because you need to do two things in order to be able to attend or to be able to leave the house. Is that clear? I think so. Now, in the case that's an OR, let's say your grade is not, we're going to see whether it's a B or not. Let's say OR, you do not have a B. So therefore, you do not have a B if your grade is less than 80. Do I need an equal sign? No. Or your grade is greater or equal to 90, correct? You do not have a B. Now let's go and run it. Enter your grade 70. You do not have a B. Now, did Java execute both statements? Now, whenever it's an AND, they both have to be true. Whenever it's an OR, only one of them have to be true in order to be able to perform this statement here. So therefore, as soon as I say, enter your grade 70%, is the grade less than 80? Yes. It doesn't matter whether this one is true or false, because whenever you have an OR, only one of them has to be true in order for this statement to be performed. In the same way that, let's say your mom, the moms are usually the nicer ones, right? Well, at least my mother was. If I ask my dad, can I go out? He'll say no. If I ask my mother, can I go out? He said, well, if you do this or this. So therefore, if you ask your mom and says, Mom, can I go out today? Can I go out to the party? You won't tell her that you're going to the rave, but you'll tell her that you go to the party. Don't lie to your parents. But can I go out to the parties? And then your mom says, well, you can go out if you take out the trash or if you clean your room. Then it's time for you to go out and say, Mom, can I go? And because there was an or, she's just going to look at the trash and say, oh, great, you took out the trash, you can go. She doesn't have to check your room because it's one or the other. Now, if that is false, then you're still going to perform this operation, right? If you did not take out the trash, your mom said, well, you didn't take out the trash, but let me see if you actually clean your room. Then this statement will be executed as well. But whenever it's an or, if that one's true, then Java doesn't have to execute this statement. It doesn't have to waste any time thinking about it. So one way to be able to use your short circuit evaluation to your advantage, and sometimes you guys will be using this, is let's assume that for whatever reason, we need to be able to divide a number by the user input. So sometimes you can say you have, how many candidates do you have? How many people do you need to divide it into? That will be that number there. And sometimes they might enter 0. And let's say we're going to say if the division, if we're going to have 200 candidates divided by the number that they entered, if we want it to be greater or equal to, let's say, 4, this is going to be either true or false. And and don't worry about so there's going to be times that we need to do this and say enter your grade. And if I say my grade is 80%, it's not going to print anything. If I say my grade is 20%, then it's going to go through it. But if by any chance your user needs to be able to type in a 0, and they do type in a 0, then you're going to get an arithmetic exception because you cannot divide by 0. So the way that we can fix this, we can use a short circuit evaluation and say if your grade is not equal to 0, and if it's equal to 0, it's not going to perform this, so it's going to skip it. So therefore, if I run it, even if I type in 0, it's not going to give me a arithmetic exception because in Java, just like in math, you cannot divide by 0. So therefore, if there's a possibility that your user might enter 0, one way to fix this is to be able to do a short circuit evaluation where we say if the grade is not equal to 0, then we can continue to evaluate this. If your grade happens to be 0, then this is going to be false because your grade is 0. Then Java is not going to take the time to evaluate this statement, and therefore it will not divide by 0. So just something to keep in mind. That is one way to be able to use short circuit evaluation. Our second lesson for today. So let me just go through and undo what we had in here. And you can do the same. Almost there. Oh, there you go. So one way to be able to read this notes, once you get to this section here, the Morgan's law, it's just like you guys covered in this before as distributed property. So we can actually distribute the 8 times 2 and the 8 times 3. So 8 times 2 is 16, 8 times 3 is 24, and then we can add them, it gives me 40, right? 2 times 3 plus 3 is 5, times 8 is 40. So the distributed property works. It works the same way with code. The Morgan's law tells me that whenever we have the not operator, we can actually take the not and distribute to each one of the components. Not times A will give me not A. Not times or, what is the opposite of or? It's an and. Not times B is the opposite of B, which is not B. So those two expressions will be evaluated in the same manner. And if we take the time to be able to create a Boolean's table, then those two expressions will have the same. Should we try it? Excellent choice. So let's try it out. So first, we're going to do one here and the other one here. And that way we can continue to practice our truth tables. So let's go and try the first one. The first one that we're going to evaluate is going to be not A and B. So we're going to make a quick table. We are going to get all the options that are available for us. It's a very quick process. First A, then B. Do you remember what the options are? 1, 1, 0, 0, 1, 0, 1, 0. Now we need to be able to evaluate A and B. So first will be A and B. Now remember, what happens whenever you have an AND? In order for it to be true, they both have to be true. So and an AND gives you an AND, and true and a true gives you a true. True and a false gives you a false. False and a true gives you a false. False and a false gives you a false. Now, let's go into the final step, which is negate each one. The opposite, now we're taking the opposite. Opposite of true is false. Opposite of false is true. True and true. So that is the outcome. Now let's try with the second one. Let's go and do not A and not B. So let's go and make a truth table. Let's go and set it up. So this is essential on your test. There's going to be times that you want to use the property, De Morgan's law. There's going to be times that you just want to go through this process and make the truth table, A and B. What are the numbers? 1, 1, 0, 0, 1, 0, 1, 0. Then we're going to take not A. Then we're going to do not B. And the last step will be to actually come up with a statement, which will be not A and not B. And that'll be our final statement. And according to this, this should be the same. So we're going to negate 0, 0, 1, 1. Opposite. Remember that you get a in this, yes, let's be careful. So this one is an OR. They cannot be both, otherwise you're going to get the wrong answer. So let me change this one. That will be equivalent. What will be the equivalency here? The equivalency, if you distribute, that's going to be an OR. So those two statements should be the same. Do you agree? Yes. So therefore, or that's a one or the other? No. One or the other? Yes. One or the other? Yes. One or the other? Yes. So therefore, those two statements are equivalency. That means that if I use the distributive property, not an A, not A, the opposite of a and gives me an or, the opposite of a B gives me not B. So there's going to be times that you can think about De Morgan's law whenever it's a simple statement. There's going to be times that you actually thinking about your truth tables to come up with the answer. Now, one way that we can do this is to be able to negate this statement. If you have this statement, and sometimes you need to be able to, it's a little challenging to be able to think of this aspect, we can, this statement that's a little more complex, we can actually use the distributive property and say, what's the opposite of greater or equal to 80%? That is going to be grade less than 80%. Do you agree? What is the opposite of an and? It's an or. And what is the opposite of a less than or equal to 89? That means it's going to be greater, not equal to. So be careful. So on the statement that we have on our screen, on this statement here. So therefore, in this statement, if I want to be able to make an equivalent statement, let me go ahead and block it off. Then what is going to be an equivalent statement? Well, let's first think about what is going to be the opposite. What is the opposite of grade being less than or equal to 80%? It's going to be grade being greater or equal to 80. What is the opposite of a or? It's going to be an and. And what is the opposite of a grade being greater or equal to 90? It's going to be the grade being less than 90. Be careful. The opposite of less than is greater or equal to. The opposite of greater or equal to is going to be less than. And now, to make an equivalent, since that's the opposite, then I'm going to negate this statement. And that means that that is an equivalent statement. So therefore, if I run it, then I should be able to do the same result as before. If I can actually come up with the correct, well, I have an extra, this is right over there. Enter your grade. Your grade is a 70, is 9B. Enter your grade. Your grade is a 95, is 9B. So this is something that you see on some code. And you need to be able to evaluate and kind of decide what it means. And sometimes it's easier to be able to do the one above, line 24, because it's a little easier to read. But you need to be familiar with that statement. That will conclude the lesson for today.